In this video, I'm going to look at designing a database for vinyl records. When we're designing a relational database, we need to make sure that we've no duplicated data. That means we need to store each piece of data only once, with the exception of our foreign keys, of course, which are copies of the primary keys and used to make the relationships between the tables. When we've got no duplicated data, it means it cuts down on errors, and we've also got more efficient storage of data. So let's have a look at this worked example for vinyl records. We've been asked to create a database of vinyl records. The database will record information about albums, tracks and artists. The album price must be between £7.50 and £10. An album has a number of tracks. Tracks are recorded by artists, and the record labels are router, long integers, many-to-many and orange. So here we've got some data, and in our own words, I just want you to just quickly describe what the database will be about. And we need to look and see if we can identify any primary keys. That's something that would uniquely identify the instance of an entity or a record in the table. And also we need to start and look about identifying any relationships. So let's have a look. We've got attributes, artist ID, we've got an artist first name, artist surname, an album release date, a track number, track name, track length, album number, album name, a record label and an album price. So the first thing is, if we just look at Benjamin Kanunga, if we just key all this data into a record in a table, it means Benjamin Kanunga, the first name and surname, will be repeated in a number of records. That's not what we want. We want to just be able to store Benjamin and Kanunga just once. We just have a look at the tracks. Can Benjamin record a number of tracks? And the answer is yes, because Benjamin has recorded track 100, 102, 107 and 109. Can a track be recorded by more than one artist? So let's just have a look. We've got 109, is that required? That's recorded by Benjamin Kanunga. It's also recorded by Selma Watson. From that we can deduce that an artist can record many tracks, but a track can be recorded by many artists. So track, let's have a look, 100, lazy processing, track length. Let's have a look, we've got track 109, is that required? So again, we only want one entry for 109, is that required? Otherwise we'll be having duplicated data. We know that an album is made up of tracks. So if we just have a look at album number here, 1 and 1, it's got 2 tracks on. So we know that an album can be made up of a number of tracks. And let's just have a look at our album a minute. So album 1 is unknown error, record label router, and it's 799. Again, that's repeated data. We only want to store once. Album number 1, album name, unknown router, unknown error, and the record label router, and the album price 799, and also the album release date that's over here, that belongs with the album as well. In our own words, we want to describe what this database is about. We want to identify primary keys. So again, if you look for things that uniquely identify something, so here we've got an artist ID. Number 1 identifies Benjamin Kanunga. Number 2 identifies Selma Watson. 3 Brian Lee and 4 Pharaoh Hills. So artist ID will a primary key. Track number uniquely identifies the track name. So we've got 100 laser processing. 102 you can't hurry the design. We've got 102 you can't hurry the design. 107 it's only a default. 109, is that required? 109, is that required? So the track number will be a primary key. We've also got the album number. 1 identifies unknown error, 1 unknown error, 6 access denied, 5 life on the bus. So the album number will be a primary key. And then in terms of relationships, we've already said that an artist can record many tracks, and a track can be recorded by many artists, and that an album is made up of tracks. So in our own words, what will the database be about? The database will store data about artist tracks and albums. Can you identify any primary keys? Something that would uniquely identify an entity. So primary keys might be artist ID, track number, album number. Can you identify any relationships? So we think the relationships might be an album contains many tracks and a track features on one album. An artist records many tracks and a track can be recorded by many artists. So from looking at the data, we can work out an initial ERD. We've got an artist can record many tracks and a track can be recorded by many artists, and an album is made up of many tracks but a track is only on one album. The next thing we've got to do is add the primary keys. So artist ID is the primary key for artist, track no is the primary key for track, and album no is the primary key for album. Now we have an issue in this database because we've got a many-to-many relationship between artist and track. We can't implement that in Access. So the solution is to break up that many-to-many into 2 one-to-many relationships. And we do this by creating a new entity and place that in the middle of the many-to-many. We give a name to the new entity by using both names from the original entities in the many-to-many. So in this case, we're going to call it track artist. And then the primary key for this new entity, we take the primary keys from the original entities and together they make up the primary key for the new entity. Let's just recap that looking at the diagram here. So we've got artist and track. That originally had a many-to-many. We've created a new entity, called it track artist. We've got the name from track and artist. And we have created a new primary key. We've taken the primary key from track number, and we've taken the primary key artist ID. We've taken that from artist ID. And together, those two make up the primary key for the new entity. The next thing to do in our design is to identify the foreign keys. So what we need to look at the many side of a relationship, and we take a copy of the primary key from the one side of the relationship. So if we just look at album and track for the minute, we know that an album is made up of tracks. So in between that relationship, we go to the one side, which is album, and we take the primary key, album number, and we put it in the entity on the many side of the relationship. Let's have a look at the relationship between artist and track artist. It's a one-to-many. So we need a foreign key on the many side of the relationship. We go back to the one side, pick up the primary key, artist ID, and put that in as a foreign key. Now, artist ID is already there because it forms part of the primary key. So all we need to do is put an asterisk behind it to denote it's a foreign key. Let's go and have a look at the relationship between track and track artist. Again, it's a one-to-many, so we need a foreign key on the many side. We'll go back to the one side, that's track, pick up the primary key, track number, and put that in as a foreign key. Again, it's already there because it's part of the primary key. We just need to put an asterisk behind it. We use the asterisk after an attribute to signify that that is a foreign key. We use the foreign keys, they're needed to be able to form the relationships between the tables when we implement this in Access. We then need to add the attributes. So what we're going to do is take each attribute and decide which entity they belong to. So for example, artist name, does it belong to artist ID or something else? Well, every time we have a change of artist ID, we get a new surname, first name. So that belongs with the primary key artist ID. Does the track name belong with track number or something else? Well, again, every time we have a change of track number, we get a new track name. So therefore, track name belongs with track number. Album price, does it belong with album ID or something else? Well, I would suggest that belongs with the album, because for each album, right, although we've got it listed a number of times, let's just go back and look at the data a minute. So if we look at the album, like album number 1, the album price is $7.99. So that album price goes with the album number. Similar with the record label, if we just look at that, Router, it's the same for number 1, so it goes with the album number. So we go through all our attributes and allocate them to our entities. So we've got artist ID as a first name and surname. Album number, the primary key, has a release date, an album name, a record label and an album price. Track, primary key, track number, has a foreign key of album number. It has a track name and a track length. And then the entity track artist has track number and artist ID as the primary keys, but separately they are foreign keys, and that's why they have the asterisk behind them. Just to summarise what we've got, all the attributes have now been placed or grouped with one entity and therefore will be stored in one place only. All attributes are what they call atomic. That means they can't be broken down into anything else. So for example, we've got artist surname, artist first name. It wouldn't be atomic if you had the first name and surname together in one field. Each entity's got a primary key. There's a foreign key on the many side of the one-to-many relationships, using the primary key from the one side of the relationship to form that relationship, and we use the asterisk to denote it's a foreign key. In that joining table, track artist, the primary key is made up of primary keys from the two tables on the one side of the relationships. So we've taken track number and artist ID. They are also individually foreign keys as well. So now we've got an updated ERD, we can now create a data dictionary.